Yes, hello grade 12s 2023. How are you today? My name is Patrick Kamala. I am a tutor and educator for mathematics and physical sciences and mathematical literacy grades 10 to 12. Now today I want us to look at sequences and series. It is the best topic in grade 12 because everything is just easy. Now this topic of sequence and series, we have got linear and then quadratic, okay? But we have got some reminders from grade 11 which I want us to look at before we proceed, okay? All right. Now we have our extra classes at Arithmetic College in Pulukwane here on 92 Skuman. If you want to get hold of us, you can reach us on 0785 222041. Now the reminders which we have the following here. One is consecutive. What does consecutive mean? It means directly follow one another. Like 1, 2, 3, 4, 5. 5 and 6, they are consecutive because they follow one another, okay? And then another term is common or constant difference. It means the difference between two consecutive terms in a pattern. That means D equals to T2 minus T1. Also you can use T3 minus T2, T10 minus T9, okay? It's all the same thing. And then you're gonna meet general term, that is Tn, also referred to as the nth term. So when we say general term and nth term, we actually mean the same thing, okay? If the question asks for the nth term, the same as asking for the general term, so it's the same thing, okay? So general term Tn and the nth term, they are the same. Now the general term for linear pattern is given by Tn equals to Dn plus C. That's one way of expressing it. And then down for quadratic is given by what? Tn equals An squared plus Bn plus C, okay? And then another one, we have the terms like T1, T2, T3 up to T100. These are terms indicated by T and the number of the terms as a subscript. So if we say T100, it means 100 terms, okay? Now in this topic, specifically we want to look at the following objectives. By the end of the topic, you must be able to understand or to know to find the values of the variables, okay? That is the A, B, and C. Also to use the values to find the general term, like they can ask you for the Tn of the quadratic, or for the arithmetic, like we're gonna see, or geometric. Also to use the general term to calculate the specific term values. We're gonna see in examples as well. And then lastly, to use specific term values to find the term number. Okay, like they can say that which term in the sequence is equal to 80. So that's when we want what? The term number. Alright, let us proceed now. Now you know what, this topic of sequence and series, we have got what we call as linear and then quadratic, okay? So we have linear and what? Quadratic. Let us start with linear. Now with linear, the constant first difference between consecutive terms, that is Tn equals to Dn plus C, whereby Tn is the general term and this is the constant difference. So notice that how this is similar to a linear function y equals to mx plus c. So this is a linear function. It's the same as y equals to mx plus c. Now steps to determine the nth term. First of all, what do? You find the constant difference, okay? You find what? You find the constant difference. That's step number 1. After that, then you substitute that constant difference and the term value along with the term number. You do what? You substitute the constant difference D and the term value along with the term number, okay? And then from there, then substitute the C and the D values to define the nth term, because we have said that our Tn for linear is given by what? We have said that Tn is given by dn plus c. So after getting the value of this c and d, you come back and substitute to get your general term. Okay, let us have an example here. They said that determine the nth term of the following sequence, that is T1, T2, T3, T4. So this is 2, 7, 12, 17. Now if I check 7 minus 2, what do I get? I get 5. What about 12 minus 7? Also get 5. 17 minus 12, I get 5. So you see, this is 5, 5, 5. Ne? So this is a constant difference, which means this is linear. Okay, so this 5, 5 which you see is my constant difference. Okay, so now if I use term 3, now if you check here, term 3, it is this one here. This is term 3. Okay, if I use term 3, this one here. Now this term 3 equals to what? Equals to 12. Okay, are we together? And this is my formula, Tn equals to an plus dn plus c. So now term 3, the constant difference is what? The constant difference is 5. Right? It is 5. Okay, that's my constant difference. It is the same 5 here. So if I put it here, I'm going to have Tn equals to 5n plus c. Now I'm going to substitute T3. You can use T4, you can use T2, and any T which you want. Okay, so in this case, if I use T3, whereby I'm going to say now 12, because that's the third term, that is T1, T2, T3. I'm going to say 12 equals to 5. Now this n is the nth term, which is the 3, the term number, then plus c. So what is 3 times 5? It is 15. What about 12 minus 15? I get my c as negative what? Negative 3. After getting my c as negative 3, then I go back and substitute to get my general term. In this case, it's going to be my Tn, like you see here. It's going to be my Tn equals to what? Tn equals to, here I have 5n, okay, equals to 5n, okay. What about my c? Negative 3 minus 3, okay. That's one method of doing this. The other method is by using this formula like this now, where we have Tn equals to a plus n minus 1 times d, this term which is most common. Okay, so whereby this a is the first term, well, that's the 2 which you see here, and then this is the common difference, that's what the 5 which you see here. So what's my first term, guys? My first term is 2, that's why there's a 2 here, and then the common difference we saw it was 5. Ne? So now note something here, when we are opening brackets, when we are distributing, ne, we say 5 times n to give us 5n, and then 5 times negative 1 to give us negative 5. So 2 minus 5 gives us negative 3. So our answer is going to be Tn equals to 5n minus 3. What a smart answer. I think we are together, guys. Okay. Alright, let us proceed. That was finding the nth term of what? A linear. Now they continue to say that determine the 100th term. After getting our Tn here, to get our T100, where there is n, we put 100. Ne? You see here my Tn, my Tn equals to 5 what? Tn equals to 5n minus 3. So if I set T20, if I put 20 here, it means what is n, I'm going to put 20. That's going to be 5 times 20, okay, and then minus what? Minus 3. But the question says find T100, or the 100th term. So I'm going to put 100 here now. I'm going to say 5 times 100, which is 500 minus 3, which gives you for what? 497. So that is my 100th term. We just substitute directly into our general term. Are we together? Okay, then next, that was to do with the linear, okay, linear sequence. Then when it comes to quadratic, this is what we do here. Now with quadratic, we have a constant second difference between the consecutive terms. This is a general term here given by Tn equals to an squared plus bn plus c, whereby that n is a general term, and n is the number of the term. Okay, so we are saying that quadratic is given by what? Tn equals to an squared plus bn plus c. I hope you see it there. And then now you see this is an squared, this is bn plus c. If you remember the parabola in standard form, it is of the form what? It's of the form y equals to x squared plus bx plus c. So this is a parabola. Okay, so this is similar to what? The parabolic, to the parabola. So alright, that's a quadratic. Okay, so now steps to getting the nth term or general term. What do you do first? First of all, you must find the constant difference. Find what? Find the constant difference. After that, what do you do next? Then use the value of the second difference to find a. Use the value of the second difference to find a in that order. After getting your a, we are saying use the value of the second difference to find a. After getting your a, then use the a value and the first difference to find b. Did you hear that? Use the a value and the first difference to find b. After getting b, now to find your c, use a and b to find c. Okay, use a and what? A and b to find c. I think we deserve an example, don't you think so? Let's find it out here. Now the question says determine the nth term of the following sequence. That is T1, T2, T3, T4. So we have 6, 17, 34, and 57. Now if I say 17 minus 6, I get 11. If I say 34 minus 17, I get 17. And if I say 57 minus 34, I get 23. You see, these are not the same, so it's not linear. Now, if I continue to say 17 minus 11, I get 6 here. And if I say 23 minus 7, I also get 6. You see, because I have the same 6 here, this is our second difference, which we usually call D2. Okay, so that's our second difference, which we call what? D2. So this D2 is our second difference. As long as it's the same, it means what you're dealing with is quadratic. Now this one is our D1. The first difference D1, we mean this value here. Okay, and then the second difference we mean this 6 here. Okay, and then our term 1 is this one here. This is T1 here. Okay, now I want you to know these formulas because you're going to be using them all the time. Okay, so the 2a equals to D2, and then 3a plus b equals to D1, and then a plus b plus c equals to 6. Okay, you can note them somewhere all the time. Okay, we are saying that we are going to use, now when you're solving this, you begin with from down here. You begin with 2a, okay, and then equate it to what? Equate it to D2. All together, so you can get your a. After getting your a from here, then now you're going to use the 3a plus b, okay, plus b. Then equate it to D2, to D1, the first difference. After getting, now because you have the a here, you're going to come here to get your b. After getting your b and a, now to get your c, now use this last one, which is a plus b plus c, and equate it to the first term of that quadratic, that is T1. Okay, let's see how it works out here. Now our second difference here is 6, so we're going to say that 2a equals to 6. Okay, so if 2a equals to 6, it means 8, 3. After getting the a, to get our b, we're going to use what? 3a plus b. Remember that our a is 3, so we're going to say 3 times 3, What is our first difference? It is 11 here. I think you see it here, guys. I'm gonna say 3a plus b equals to 11, but I know my a3, so I can get my b. After getting my b as 2 here, and I have the a, I go ahead to use term 1, that is a plus b plus c equals t1, which was 6. So I'm gonna say that's because my term 1, t1, as you can see here, guys, this one here, it is 6. I'm going to that 6 equals to a, that is 3, plus 2 plus c. 3 plus 2 is 5. What about 6 minus 5? I get 1. So my c is 1. So after getting the c, b, and a, now I have my what? My general term of the quadratic, which is what? Which is tn equals to 3n squared plus 2n plus 1. Hope we are together. Let us proceed. Now we have in grade 12 what we call as the arithmetic sequence. Okay, let us talk about it now, because it is gonna be coming in your test all the time. Okay, now what is an arithmetic sequence? What is an arithmetic sequence? Okay, now arithmetic sequence is formed by adding a common difference to the previous term. Okay, so the common difference here, d equals to t2 minus t1, also the same as t3 minus t2. What am I talking about here? Let me elaborate this properly before we continue. Now, if I've got my arithmetic sequence like with terms, what I'm saying, t1, okay, use blue now. If this is t1, okay, and then followed by t2, okay, then followed by t3, okay, and there's so many of them. So now to get my common difference, I can say t2 minus t1. That's what you see here. Okay, I can say what? I can say t2 minus t1. That's what you see here. That's t2 minus t1. Alternatively, I can use t3 minus t2. That's what you see here now. So they all give me my common difference, which is d. And then our general terms given by tn equals to a plus n minus 1 times d. That is for arithmetic sequence. This is tn equals to a plus n minus 1 times d, which is the common difference by t in general term, n number of the term, and then a is the t1, and this is the first difference. Now we have got the steps to determine the nth term here. What do? First of all, you find the constant difference. Okay, you find the constant difference, and then use t1 as a to write down your general term. Because after getting your constant difference here, you just put it here where there is d, and then the a, check in the given sequence, then you substitute, then later simplify to have your general term. I hope we are still together. Example, they say, given -6, -2, 2, 6, 10, up to 110, determine the general term. Then which term in the sequence exceeds 84, determine the value of the 14th term, then how many terms are there in the sequence. So this is -6, -2, 2, 6, and 10, up to 110. Now first of all, let us find out, is it arithmetic? Let's check properly. Now -6, -2, 2, 6, 10, and up to 100. Now what is -2 minus -6? The two minuses give me a positiveness, so it becomes -2 plus 6, which gives me +4. And then 2 minus -2, it gives me +4 as well. Then 6 minus 2 gives me 4. 10 minus 6 gives me 4. So you see, because I have got the common first difference, which is 4, 4, it means this is arithmetic. So I go ahead to get my general term. We said that you're going to use your common difference, okay? Use the common difference, okay? And then also use the first term to get your general term, which we said is Tn equals to A plus n minus 1 times D. What is my A? My A is -6, guys. What about my D? My D is 4. Note what we said when we are distributing here. We said we're going to say 4 multiplied by n, you get 4n. And then 4 multiplied by -1, you get -4. In other words, here we have -6, okay, all together. Then 4 times n, that is 4n, okay, that is 4n. And then 4 times -1, that's -4, okay. Now collect like terms here. Now if you check here, this 4n does not have any other like term, so I leave it the way it is. And then -6 minus 4 gives me -10. So that's how I get the answer here of 4n minus 10 to be our general term Tn. Hope we are together, okay? Now they said that which term is greater than 84. After getting our Tn here as 4n minus 10, we say greater than 84, okay? And then we solve this inequality. Now this -10 becomes positive, give us 94 this side, then divide by 4, which gives us n greater than 23,5. So we take the immediate whole number after 23,5, which is 24. So it means the term which is bigger than 84 is going to be the 24th term, okay? And then they said that also after that, what do we do? Part C, the value of the 14th term. Again, because we have our Tn here, guys, which is 4n minus 10, we can get our 14th value by saying what? By saying T14 equals to 4 multiplied by 14 minus 10, which gives us 46. I hope we are together. And then they said that also the number of terms, if you remember the question said, determine what? How many terms are there in the sequence? So to get the number of terms here, because we have the last term here, you remember that was 110. Next one here, I'm going to use my general formula, which is Tn equals to 4n minus 10. Then I equate it to 110 to get the value of number of terms, which is n. So if I do so, I'm going to have Tn equals 4n minus 10. I'm going to say 110 here equals 4n minus 10. So minus 10 becomes positive here, which gives me 120. 120 divided by 4, it gives me 30. So there are 30 terms in this what? In this sequence. Okay, let us proceed. Hope we are still together. Now, again, another example here. They said that m, 2m plus 2, and 5m are the 3 consecutive terms of the what? Of this sequence. Okay, of the sequence. Then they say, what must we do? They're saying that we must do what? We must determine the value of m. So for that matter, what are we going to do to get our value of m? Okay, to get our m, remember that we're saying this is arithmetic, né? What is so special with arithmetic, guys? If you remember, we said that if I have my terms, okay, my first term, this is my first term m. What's my second term? It is 2m plus 2. Okay. What's my third term? It is 5m plus 3. Okay. And because they are arithmetic sequence, it means that they must have the same common difference. So for me to get the value of m, I'm going to use t2 minus t1 equals to t3 minus t2. Then I can get my value of m like this. I'm going to say t2 minus t1 equals t3 minus t2. So what's my t2 here? You can see it is 2m plus 2, which you see here. What about t1? It is m, that's minus m here, equals to t3, which is 5m plus 3, and then minus t2, which is 2m plus 2. So when I open brackets here, I'm going to get 5m minus 2m, which is 3m, and then 3 minus 2 giving me 1 here. Now the other side I have, this is 2m minus m, which gives me m here, then plus 2. So this is 3m becomes minus, so m minus 3m gives minus 2m, and then this positive 2 becomes minus, so 1 minus 2 gives minus 1, so m equals to 1 over 2. Hope we are together. So our m is 1 over 2. After getting m, they say now, if the 12th term is 28, determine the sequence. So they're saying the 12th term is what? It is 28. I want the sequence now. So after getting my m, I can come back to get my t1, my t2 minus t1, because I know the m now. So this is my common difference here. And then I know that Tn equals to a plus n minus 1 times d, okay? And remember that I have, they said if the what? Let's check it again. They said that if the 12th term is 28, determine the sequence. So meaning T12 is 28. So meaning that where I have n, I'm going to put 12, then I equate to 28 here, okay? Now that my d is 5 over 2, which is here, guys. So I can get my a. So this is my a, which is a half here. So that is a equals to a half. After getting my a, then I can have my general term Tn equals to a half plus n minus 1 times 5 over 2. Hope we are still together. Now, however, if the question wanted us to get the first 3 terms, that is for the sequence, then we can do what? We can substitute them. We can say T1 equals to m, which is a half, T2 to m plus 2, which is 2 into a half plus 2, which gives us 3. And then T3, it is 5m plus 3, which is 5 into a half plus 3, which gives us 11 over 2. So the sequence would be, what would it be? A half, 3, and then 11 over 2. Hope we are still together. Hope you're still together, guys. Next. Another way they ask this question, they can give us 2 different terms. They can say, find arithmetic sequence if the 6th term is 10 and the 4th term is 58. Did you hear that, guys? They want us to find arithmetic sequence. That's the question. We need to find arithmetic sequence if what? If the 6th term is equal to 10 and also the 14th term is 58. Okay, so I'm going to form an equation for this information here and another equation from this information here to solve the 2 simultaneous equations, and later I get my arithmetic sequence. Let's go. So note our Tn equals to a plus n minus 1 times d. This is general term for arithmetic because the question said so. That's why we are using it here. So now if I substitute here, if I do substitute, I'm going to have, remember they said that the 6th term is 10, which means if I put 10 here, I must put 6 where there is n. Okay, so what is 6 minus 1, guys? That is 5. 5 times d, I get 5d, then plus a here. So that one becomes my equation 1. Meaning 10 equals to a plus 5d is my equation 1. Also, don't forget that they said the 14th term is 58. So if I put 58 here, the n must be 14. What is 14 minus 1? I'm going to get 13 times d. That is 13d, then plus a. Okay, so it's going to be 58 equals to a plus 13d. That's equation 2. So if I subtract the 2 equations, okay, the a's are going to disappear, okay, because a minus a is 0, and then 13 minus 5, it is 8d, then 58 minus is going to be 48, so I can get my d here by dividing 48 by 8, which gives me 6 as my d. After getting my d, to get back my what? To get my first term, I can use any of the equations. Okay, I can set 10 equals to a plus 5d, but my d is now 6. So what is 5 times 6 going to be? We know it is what? It is 30. What about 10 minus 6? It's going to be negative 20. So my a is going to be negative 20 here. However, if the question wants us to find the sequence, it means we find only the first 3 terms. Now we can find Tn equals to a by putting in 1, because we have the a and d, right? So we put T1, we're going to say negative 20 plus 1 minus times 6, which gives us negative 20 as our T1. And then if I want to get my T2, I'm going to put 2 now here. I get negative 14. And also T3, the same thing, I get negative 8 here. So it becomes negative 20, negative 14, and what? And negative 8. Hope we are together. Okay, let us proceed. Now also, we have what we call as, apart from arithmetic, so we have what we call as geometric sequence in grade 12 as well. Now the geometric sequence, it is also interesting, and we need to know all about it. Geometric sequence. Geometric sequence. So what do you mean exactly by geometric sequence? With the geometric sequence, a sequence formed by multiplying the previous term by a common ratio. That is geometric sequence. What did I say? It is a sequence which is formed by multiplying the previous term by a common ratio. So this R is a common ratio, so it means that our R equals to T2 over T1, which will also be the same as T3 over T2, so it's going to be the same number. Okay, so the general term Tn is given by Tn equals to A multiplied by A power R power n minus 1. This is our Tn for the geometric sequences. So be careful, guys. If the question talks about geometric sequence and they want to find general term, you must use Tn equals to A multiplied by R power n minus 1. Okay, we have these steps here to determine our nth term. Don't forget that A is T1, R is the common ratio. What about Tn, general term? What about n, number of the term? Okay, now what we do here to find our general term, first of all we find the common ratio and then use T1 as A. For example, given the sequence 6, 18, 54 and 118098, determine the next two terms, the nth term and how many terms are there in the sequence. Okay, so first of all, if you check here, like we said, guys, that this is our T1. This is our what? This is our T1. So this is our T1 here. This is our T1 here. This is our T1. This is our T2. Okay. This is T3. Okay. So because we have got those first terms, we can check. We can see if I say 18, that is T2 divided by T, because this is T1, like we have said. This is T1. This is T2, and this is T3. Check if I say that T2 divided by T1, I get 18 divided by 6, which gives me 3. Okay, beg pardon here. If I divide 18 by 6, I get 3. Then if I divide also 54 by 18, I get 3. Okay, so because I get my common ratio at 3, okay, then I'm going to go ahead to use the common ratio and to use the first term to get my general term. Okay, so in this case we say that our Tn equals to A multiplied by the common ratio power n minus 1. Hope you remember that. So that's what we have here. Our A, like we said here, our A was 6. You remember that? A is the 6, which 6 you see here, and that's why we put it here. What about our common ratio R? It is 3. Okay, then power n minus 1. Okay, so meaning that here we have our T4 as 162 and T5 as 486. Because the question wanted, let us check the question one more time again, please. Come on. They said that the next two terms. Okay, so mean that after getting our common ratio and we have our Tn here, we can get the next two terms. That means after T3 we're going to find the T4 and T5. So to find our T4, it's going to be AR power 4 minus 1, which is going to giving us what? 162. And then to find the T5 is going to be A, which is 6 power 3 power 5, times 3 power 5 minus 1, which gives us what? 486. So these are the next two terms of this sequence. Hope we are still together. Okay. Alright, let us continue. Okay, so we are saying that they wanted the next two terms, ne? This one is here. Next two terms here. What about part B? What do they want in part B? What must we find? Let's check it again. The nth term. Because we have the common ratio and also have the first term, so that is so simple. It's going to be 6 multiplied by 3 power n minus 1, okay? But what do we know, guys? We know that our 6 is the same as 2 times 3, ne? So because of that, I know that 3 is the same as 3 power 1, okay? And if the base is the same and I'm multiplying, I can add the exponent. It's going to be 1 plus negative 1 gives me 0, then plus n. So it becomes 2 multiplied by 3 power n. So this is our Tn here. This is our Tn. Okay. Let us proceed. Then part C, what did they want? They said how many terms, right? They said how many terms are there in the sequence. Now this is our last term here, which you see, guys, properly. This is our last term here. So with this last term and the general formula or the nth term, we can use it to determine how many terms are in this geometric sequence by equating some to the what with the general term. Ne? Let's do that now. Now if we do this, we're going to have Tn equals to 2 multiplied by 3 power n. So if I divide it by 2 first, we're going to get 59049 equals to 3 power n. Now, if you check on your calculator, this one is the same as what? What are the factors of this? If I use my calculator, I'm going to have 3 to the power 10. 3 to the power 10. So I'm saying this, that here, when I get here, this point from here, if I express this one in powers of 3, I have 3 to the power 10, okay, equals to 3 to the power n. So because I have the same base, I can drop the base, then I'm going to get my n as what? I'm going to get my n as 10. So that's why I get the answer here at n to be 10, okay? Alright, alternatively, I can use logarithms. I'm going to say n equals to log of base 3 of this number here. This one here, which gives me still 10 as my answer still. So we'll talk more about logarithms as we continue. Don't worry about it for now. Alright, hope we are together. Don't forget our extra classes here at Smart Fizz Math at Lotec College in town in Polokwane here, okay? Or you can call us on 0785222041 here. Alright, let us continue. Now we have another example 2. It says that 4g minus 2, g plus 1, g minus 3 are the first 3 terms of a geometric sequence. Underline the important terms, guys, important information. So they're saying that this is our first term, this is our second term, this is our third term, and they say they form a geometric sequence. Note this from the start that geometric sequence, it means we have a common ratio given by T2 over T1 equals to T3 over T2. What about arithmetic sequence? We have a common difference, which is D equals to T2 minus T1, also the same as T3 minus T2. Hope we are together. That was just a reminder. Now, because it must be the same common ratio, T2 over T1 is going to be this g plus 1 over 4g minus 2, which you see here, and then equals to T3 over T2 is going to be g minus 3 over g plus 1, okay? Alright, hope we are together. Now to solve this one here, I'm going to cross multiply. I'm going to say this time with this one here, because this time with this, so this one g plus g times g plus g, it gives me g squared plus 2g plus 1. I can expand it here as usual. After this, I'm gonna collect like terms, okay? You can see 4g squared minus g squared gives me 3g squared. This is 2g, it becomes minus, so minus 14g minus 2 gives me minus 16g. What about positive 1 becomes a minus? Gonna be 6 minus 1, which gives me what? Which gives me 5. So I solve the quadratic here. This is 3g squared minus 16g plus 5 equals to 0. So I can factorize it. If I do so, I'm going to get 3g minus 1 into g minus 5 equals to 0. Because this is 0, I'm going to use the zero product rule, which means either 3g minus 1 equals 0, which gives us g equals to a third, and then g minus 5 equals 0, which gives us g equals to 5. Okay, so after that, but this g cannot be what? Cannot be a third because it's not an integer. So I continue to get my t1 equals to 4g minus 2, but my g is 5, so it gives me 18 here. And then my t2 equals to 5 plus 1, which is 6. What about t3? It is g minus 3, which is what? Which is 2. So it means my sequence is what? It is 18, 6, and then 2. That's what they wanted. Okay, let's check it one more time. They said that this one, this, and this, they are the first 3 terms of a geometric. They said that determine the value of g if g is an integer. So because a third is just a ration, which is just a fraction, we don't take it. Okay, that's why we left it. Okay, now they said write down the nth term of the sequence. After getting the first 3 terms, then we can now find the common ratio, and then we have the first term. Then we can get our this. So also our common is going to be 6 over 18, which is 1 over 3. What about our first term? It is 18 here. So if I have here, I'm going to say 18 times 1 over 3. That's common ratio. Power n minus 1, which gives us now what is 18? Same as 2 times 3 squared. Now here I can say 3 power negative 1, then power. If I take it in the numerator, it becomes power minus n plus 1, which gives us what? 32 times 3 power 3 minus n. Hope we are together. Okay, let us proceed. Now, still more about this geometric here. We have example 3. They say the 6th term of a geometric sequence is root 3 and 11th term is 27. Determine the sequence. So not important terms again here, where they are saying the 6th term it is root 3. What about 11th term? 11th term is what? It is 27. Okay, so but they're saying it is geometric. So being a geometric, I must know my formula for the Tn. Tn equals to A multiplied by R power n minus 1. Okay. Oh yeah, we are saying that you have to check the important terms. They are saying the 6th term is root 3, but our Tn equals to A multiplied by R power n minus 1. So if our n is 6, we must equate to root 3. That's why equating to root 3 here. So it means root 3 equals to A power n, but n is 6. What is 6 minus 1? Is going to be 5. So it becomes A power a multiplied by R power 5. This one becomes equation 1. Okay. Now if our n equals to 11, we equate what to 27. That's what we're doing here. The next step. So 27 equals to what is 11 minus 1 will be 10. 27 equals to a multiplied by R power 10. That's equation 2. Now here, unlike in arithmetic where we subtracted t2 minus equation 2 minus equation 1, here we just divide them to cancel the a's. Okay, if I divide the equation 2 by 1, you see the a's are going to cancel this a, we cancel this a here, and when they do so, then now I can proceed with only the common ratio in my what? in my equation. Okay, so if you check this a, you can cancel this a here. Okay, I'm left with r power of 10 divided by r power of 5. So because I have the same base, we said in division you subtract, it's gonna be what's 10 minus 5 is gonna be power 5 here. This is 27 divided by root 3. So what do I do here? Now I know the same as saying power half, so take it up. It's gonna be 3 minus a half, which is 2.5. So it's gonna be r power 5 equals to what? Equals to 3 power 5 over 2. Okay, so to find my r, what do I do, guys? I find the fifth root. I find what? I find the fifth root. So let me explain properly here. We are saying here that you see here I have r power 5, right? R power 5, okay, equals to 3, okay, power 5 over 2. Power 5 over 2, the same as 2.5. Okay, so to get my r, I power both sides by what? By 1 over 5, like this. So I say power 1 over 5. Okay, this side, because I have now 3 power 5 over 2. Okay, then power what? Power 1 over 5. Okay, so if I simplify here, I'm gonna cancel 5 times 1 over 5 gives me 1. That's why I have r here. I'm gonna have now 3. Sorry, I'm gonna have what? I'm gonna have 3 power. This is 5 over 2. 5 over 2 multiplied by what? By 1 over 5. Okay, so if I cancel by 5 here, I get 1. By 5 here, I get 1. So I'm left with actually r equals to 3 power half. R equals to what? 3 power a half. So 3 power half is the same as root 3. That's why it's gonna be root what? Root 3. So that's my r. My r is what? Root 3. So that's why it is here. So after getting our common ratio, we can go back to equation 1 to get our first term. Okay. Okay. Now after getting our common ratio here as root 3, we come back here to get our first term. So if you check this one here, I'm looking for, so I'm gonna say root 3 divided by this one, power what? Power 5. Okay, so if I simplify here, I'm going to get 1 over root 3 power 4. Okay, alright, so which gives me a equals to 1 over 9. Alright, now what did the question want us to get? They said, what must we determine? Check it again. They wanted the sequence. Determine the sequence. I mean they want the first 3 terms, okay, of this geometric here. After getting our a and the common ratio, we know that to get our first term t1, we just use our where there's n, we put 1, which gives us 1 over 9 here. What about to get our t2? To get our t2, now I'm gonna put 2 here, so this was for t2. I beg your pardon, guys. This was for t2. I'm saying here to get our t2, okay, our t2, I'm gonna put 2 here now. What is 2 minus 1? It's gonna be 1. That means 1 over 9 times root 3, which is 3 over 9. That's our t2, our second term. Then to get our t3, I'm gonna put 3 here. What is n now? So this was t3. I beg your pardon, guys. So about that. So what is 3 minus 1? I'm gonna get 2. Now root 3 squared gives me 3. Then divided by 9 gives me 1 over 3. So this is our t3 here. So our sequence is going by 1 over 9, root 3 over 9, and then 1 over 3. Hope we are together. That was to do with geometry key. Okay, let us proceed. Now apart from doing calculations, we have got some formulas when it comes to arithmetic series and the geometric series. The others were sequences. Okay, so now there's a difference between a sequence and a series. Okay, now What's the difference? Now a series is the sum of the number of terms in a sequence, and it is written by Sn. I repeat, what is a series? A series is the sum of a number of terms in a sequence and is given by what? By Sn. So you have to call this arithmetic series and geometric series. Okay. So here we have general term for an arithmetic series that's given by Tn equals to A plus n minus 1 times D. Okay. And then hope it is clear now. Yes. What about the sum of the arithmetic series given by Sn equals to n over 2 into 2a plus n minus 1 times D? Or if we have the last term, we can use Sn equals to n over 2 into a plus the last term. We are going to use these formulas a lot. We are going to use them a lot. So this is our Tn here. Okay. And then this is our sum of the first n terms. If we don't know the last term, however, if we know the last term, we can find the sum of the first n terms using, again, Sn equals to n over 2 into a plus last term. Ne? Okay. Now, this proof here is examined. Please, let's go through it. Now, arithmetic series has got a proof of the sum, which they ask in your test. So, let us check it out. Now, this proof of arithmetic series, ne? Sn is the sum of the first n terms, ne? So they're gonna be a plus d, then a plus 2d plus so many plus a plus n minus 3 times d plus a into n minus 2 times d, then plus a into n minus 1 times d. Okay. So now if I revert them, like if I change them and I start with this one here, this side, I'm gonna have still Sn equals to a plus n minus 1 times d, like I'm starting from this side, ne? Then plus n into n minus 2 times d. I'm on this one now. Then plus a into n minus 3 times d. I'm now on this one here. Then plus so many up to here again. That is a plus 2d. And then plus a plus d, and then plus the first term, which is a. Now if I add the first sum of the first n terms plus the next same, it's gonna give me 2Sn. I get what, guys? Here I get 2Sn. And what about these other terms? Let's check it out. Please pay attention here. Now note that I'm adding, ne? I'm doing what I'm adding. If I add Sn plus Sn, I get 2Sn, ne? This is a plus a. I'm adding. Okay, I think I better put them like this to make them proper, for you to see them properly. Okay, I'm adding these ones. Okay. And so on. And so until the end, I'm adding them in this order here. I'm adding them in this order here. Okay, let's check them now properly, because once you understand here, you will not have to cram. Okay, you will not have to cram. Okay. All right, now check here. I'm adding this one in here. Ne? A plus a, I get 2a, then plus n minus 1 times d. That's why you see it here the way it is, guys. Hope we are together. I get a plus a, I get 2a, then plus n minus 1 times d. That's what you see here. Are we together? Now check here. This is a plus d, then plus a into n minus 1 times d. Let's check it out properly, because we have to understand this properly here. Okay, now I have the a plus d, right? This a plus d, that's what you see here, a plus d, and then plus this a, right? Then plus n minus 1 2 times d. What is d times n? I say it is nd. N what? Nd. Okay. What about d times negative 2? It's minus 2d. Can I collect like terms, please? Yes. What is a plus a? I get 2a. I get 2a. What about d minus 2d? I get minus d, right? I get minus d. So this is nd, but we said d minus 2d gives me what? Minus 1d, minus 1d. Okay. Now if you check properly here, this d is common here, so I can write it as 2a, then plus, because d is common, I can factor it out. I'm left with this n, then minus 1, and then times d. Okay, now if you check what I have here, that is 2a plus n minus 1 times d. That's what I get here. Remember, it was the first thing which I got here as well. It was also 2a plus n minus 1 times d. So actually, when you add these ones as well, you're going to get the same answer here. And so on all of them, when we add all of them in that order, we always get 2a plus n minus 1 times d. Did you hear that? Let me say it again. When I add these ones also, I'm going to get 2a plus, open brackets, n minus 1 times d. Even though when I add, I'm going to get what? I'm going to get 2a plus n minus 1 times d. What about here? I'm going to get again 2a plus n minus 1 times d. Now this series was for any times, which means I'm going to get the same answer how many times? Any times. That's why we have got to multiply this one multiplied by n. This n which you see here, it shows us that these sums, they have been as many as this n number. If n was 10, it's going to be 10 multiplied by this, okay? But because I'm looking for my Sn, I divide by 2 both sides. Now it's going to be now divided by 2. It gives me Sn equals to n over 2 into 2a plus n minus 1 times d. So that's how we do it, guys. I hope we are together. This is very common in your test. Please know it, how we prove it. If you don't get it, please, you can come to our extra classes here in town, Roster College Polokwane. Surely you will understand it, or you can just inbox me, okay, to explain much more. Alright, let's now look at examples using this formula here. Okay, example 1. They say determine the sum of the following. We have the first 25 terms of 18, 13, 8, 18 plus 13 plus 8 plus and so many. We want to find the first, determine the sum of the following, the first 25 terms, which means I'm looking for S25. So if I check here, what is 13 minus 18? I get negative 5. What about 8 minus 13? I get negative 5. Meaning my common difference is negative 5. So my formula says Sn equals to n over 2 into 2a plus n minus 1 times d. Okay, don't forget that in this particular question, because we want the first 25 terms, I'm looking for S25, right? And this is my first term, which is 18. And this is my common difference, which is negative 5. Okay, so the formula says Sn equals to n over 2 into 2a plus n minus 1 times d. I'm looking for S25, that's S25 here. I'm going to put 25 where there is n, okay? 25 here as well, okay? What's my common difference? Negative 5. So when I simplify it, I'm going to get what? Negative 1050. That's my answer for the first 25 the sum of the first 25 terms of this arithmetic series. Okay, hope we are together. Let us proceed. Next, they say determine the sum of the following, that is the series 5, 8, 13, and so many up to 35. So here I have the last term and the first 3 terms. So what's my difference? What is 8 minus 5? I get 3. What about 11 minus 8? I get 3. So that's my common difference, which is 3. Now we said if I have the last term, we said you can use Sn equals to what? N over 2 into a plus this term. That's going to be S. Because I don't know how many terms they are, I must get the number of terms first by using Tn equals to A plus N minus 1 times D. Okay. Or did I say? I must use Tn. I must use what? I must use Tn. I must use Tn, the nth term of arithmetic. I must use Tn equals to A plus N minus 1 times D to know the number of terms. Okay. Oh Jesus, I beg your pardon here. N minus 1 times D. So N minus 1 times D. Okay. Okay, then now because I have the last term which is 35 here, it means I'm going to equate to 35, right? To know how many terms. So my first term A is the 5, it's going to be 5 here. Okay. Plus, what about my common difference? We saw it was 3, okay, multiplied by 3 here. Okay, equal to 35. Okay, so if I say 35 minus 5, what do you get? 35 minus 5, you get 30. Then divided by 3, you get 10. Then plus 1, you get n as 11. So that's why my n equals to 11 here. After getting n as 11, I come and say my Sn equals to n over 2 plus into a plus L. So meaning I'm looking for sum of the first 11 terms. So which gives me 220 surely here. Are we together? Then another form of this question, they can ask it like this. They can say the 6th term of an arithmetic sequence is 23 and the sum of the first 6 terms is 78. Determine the sum of the first 21 terms. I repeat, or let's mark out the important information here. They said that the 6th term, okay, the 6th term of arithmetic is what? Is 23. And now they say that the sum of the first 6 terms is 78. Wow, okay. The sum of the first 6 terms is 78. Determine the sum of the first 21 terms. Oh, I need S21 now. That's what I'm looking for. Okay. So because they're saying it's arithmetic, and they're saying the 6th term is 23, I know that any arithmetic is going by what? Tn equals to A plus N minus 1 times D. Okay. Are we together? So if I look at the first given information here, they say the 6th term, which means if I put 6 where there is n here, I must equate to 23. That's what we do here. We're going to say 23 equals to A plus 5D to get our equation 1 here. Because our n is 6, what 6 minus 1 get is 5 times 5D. That's our equation 1. But they said also that the sum of the first 6 terms is 78. So, meaning S is 6. Okay, S what? S is 6. It is 78, which means if I put 6 now where there is n in the sum formula, I must equate to 78. Okay, so what is 6 divided by 2? I'm gonna get 3. Okay, and then what about here? I'm gonna put what? What is 6 minus 1? I get 5. 5 times D, I get 5D. Okay, are we together? So now what do I get here? What do we have here? We're saying that let's check totally here. You get him 78, ne? Okay, so this is 78 there, which you see guys there. We are together at 78. Then our n, because we're talking about sum of first 6, what is 6 divided by 2? We get 3. Okay, open brackets, then 2a 2a, and then plus what? Plus, what about 6 minus 1? We get 5, then 5d. 5d. Okay. Open brackets. Now what do you get here? We're going to get, it's going to give us, what is 6? 3 times 2a, it gives us 6a. I'm going to have 6a. I'm going to have 6a, then plus 3 times I'm going to get 15 here. 15d, okay, that is equal to 78, okay, that is 78, that is 78 equals to that. So if I say this is my equation 2, now my equation 1 was 23 equals to a plus 5d, that's equation 1 here. So if I say equation 2 minus equation 1, I'm going to say 78 minus 23, what do you get? What is 8 minus 3? What is 8 minus 3? I get 5, okay, right? What about 7 minus 2? I get 5 as well, okay. I get 5 as well. Then equals to, this side I have 6a minus a, I get 5a. I get 5a, right? I get 5a, and then plus what? Here I have 15d and minus 5d. What do I get now? I get 10. So, okay, so let me do it like this. I beg your pardon, guys. So for me to make it simple, so because I want, okay, we are saying here that to solve these two equations, what can we do here? If I check here, this is a plus 5d, and this is 78 equals to 6a plus 15d. So because this is a and this is 6a, and this is 5d and this is 15d, so let me eliminate the d's first. I can multiply here by what? By 3, because multiply by 3 here like this. Okay, it's gonna be 3 multiplied by 23. Okay, multiplied by 23, and then everything here. So what times 23? It's gonna be 69. 69 equals, what about 3 times a? It's gonna be 3a. Okay, what about 3 times 5d? It's gonna be 15d. 15d here. Okay, and then now I can set this my equation what? Equation 1 now. So equation 2 minus equation 1 is gonna be 78 minus 69. Okay, so 78 minus 69, what do you get? What is 18 minus 9? Because 8 minus 9 I get, it's not possible. 18 minus 9 I'm gonna get 9 there. I get 9. Okay, get 9, and then yeah, actually it's gonna be 9. So it means 9 equals to what? Equals to 6a minus 3. I'm gonna get 6a. I'm gonna get 3a, right? Sorry, 3a. What about 15d minus 15? I'm gonna get 0. So divide by 3. So my a is what? My a is 3. So after getting my a at 3, I come back to get my d. When I use any of these equations to get my d now, I can use the first one again here. I can use 23 equals to a plus 5d. Okay, because my a is 3, I'm going to say 23 minus 3 equals 5d, which gives me d as 4. After getting d as 4 and the a as 3, then I come back to check what they want. I said I must find the sum of the first 21 times. So S21, I mean my n is 21 and my a is 3 and my d is 4. So if I simplify, I'm going to get what? 903. Hope we are together. Okay, that was to do with arithmetic series. Let us proceed to geometric now. Now, geometric is also interesting, and I think we can do that in our next video. Thank you so much for watching. Check out these questions to try them out. Try these questions out. Try these questions out. Try these questions out here. This one, followed by this one, and this one, and this one, and this, then this one here lastly. Thank you so much for watching. Again, my name is Patrick Kamala. I'm a tutor and educator for mathematics and physical sciences and a mathematical literacy grades 10 to 12 here in town, Lukwando State College.